I'll tell you when it's live. Yes, we are live. Okay, so folks, this is the Mountain View SF Bitcoin Devs meetup. We have with us Nikolai Mushegian. He will give us an inside, in-depth view into BitShares. It's all yours, Nikolai.
Okay. Thrown in. So what's the theme of this meetup? Is it just like all about BitShares in general? What am I supposed to talk about?
So most of the folks
all about BitShares.
Yeah, most of the folks here are deeply technical, so they, you can sort of bypass the overview kind of thing. I mean, we want some depth, right? Exactly what makes BitShares as a blockchain valuable? What are the different parts of BitShares? Is BitShares? All right. Okay. So, folks, this is the. Okay.
Hold on. Sorry. Keep talking.
All right.
Trying to find the Google Hangout thing.
So the idea is that you tell us a little bit about BitShares, about the different parts of BitShares. There's BitShares Music, there's BitShares X, there's all these different BitShares. Maybe exactly what is a DAC? I mean, there are so many different versions of it. I mean, how do we conceptualize this? And from a developer perspective, how do we sort of enter the whole BitShares world? How can we fork it and start using it? What are your test runs like? We understand maybe a little deeper understanding of DPoS, how it exactly works, how we can actually sort of tap into it. I mean, more than the overview, right? I mean, do you have each node negotiating? How does the voting take place? I mean, do I vote for 101 people? You get it. I mean, we want like inside.
Yeah. Cool. Okay, so usually where I start with this sort of audience is I basically say, so what is a DAC? A DAC is just a metaphor we use to think about all the same cryptocurrencies and stuff that you guys are all already working with. So one thing Dan says a lot is that people say, okay, what is Bitcoin? Bitcoin is a type of money, but money is just what you use something for, and it's not what it actually is. So we try to come up with the closest. If you try to analyze the economics of any crypto equity, you find that they look more like shares in a company than like currency. They look more like assets, just like a certificate for gold, than they do like a currency, or a certificate backed by ownership in a co-op. Basically, where this metaphor leads us is trying to design crypto equities that are profitable. And what that ends up looking like is it looks like there's a company that's providing services. But there's not actually any company. It's just a sort of autonomous incentive structure built around the fact that you can make you can basically take some types of existing business models, which are all just simple information services, and outcompete traditional businesses. Even though the thing that's competing with the business, it's not actually a company. It's not any sort of legal entity. It's just an incentive structure put together using blockchain technology. So let's analyze like a Bitcoin or an altcoin under this metaphor. So in Bitcoin, you pay miners, transaction fees go to miners, and you pay them for validating transactions on the network and maintaining consensus. You also subsidize miners by printing new coins, right? The first thing I always tell people is just always think of the coin supply or the token supply or the shares in terms of percent of the DAC as a whole, and only think of it in those units. So you're basically, in Bitcoin, you're paying 100% of the fees that you've paid to the network go to miners, and an additional, right now it's like $500 million each year, about 10% per year, is printed, which is the same thing as taking it away from people that have Bitcoin and giving it to new people. And those people, what do? Well, they just spent almost $500 million on power, basically. Power and the manpower you need to run these mines and the initial capital into building mining hardware and stuff like that. By design, that barely breaks even. And so you're basically paying $500 million a year to just get burned up. And a little bit more of that goes to miners to actually spend on stuff. But it's not clear that even if you somehow made them use less power, but still paid them the same amount, it's not clear how you would even incentivize them to do good stuff for Bitcoin very directly. So under that analysis, Bitcoin is extremely unprofitable to hold. It's only gone up in value because the capital pouring in is more than what people are slowly sucking out by just giving it to miners. Yeah, and so Bitcoin only has one source of income. It's the transaction fees that you pay. So think of Bitcoin as shares in a payment processing company. Its advantage over all the other companies is that it lets you do all these things that you can't. You know, it's fast. You can send it to whoever you want. It's fairly anonymous, stuff like that. And it's like, hey, I can transfer my shares in this manner that's useful. No other company can do that. It sort of generates demand for itself by providing some service. So all that these DACs are, so I'll talk about BitShares X and then the DNS DAC.
Okay.
I'll probably actually talk about them in reverse order. We just make an altcoin. We say what kind of service can this altcoin / blockchain system provide, and how do we make the amount that the DAC is amount of value that the DAC is consuming or producing greater than the amount that it's consuming, and how do we make that difference somehow capturable for the owners of the DAC? So DNS is an easy example. First of all, because there's already a DNS DAC out there. There's Namecoin, right?
Right.
You guys are familiar with Namecoin?
Yes, we had someone from Namecoin give us an in-depth 3-hour presentation on it.
Oh, okay, great. So you know, imagine everything is exactly the same about Namecoin, except one, it somehow doesn't require. Okay, I'm giving this is a conference with the Bitcoin Dev Meetup in Mountain View. Dan Larimer is here. I don't know.
Oh, okay.
If you want to say hi for a second, then I can.
Hello, everyone.
Hi, everyone. So this is the SF Bitcoin Devs in Mountain View. We want to do a deep dive. We're thanking Nikolai for it.
Thanks, Nikolai. I'm just going to be...
Okay, are you working? Okay. Okay, so he's busy, but I can keep talking. So yeah, so Namecoin is the first example. It's really easy to understand, really easy to analyze the economics. What's their income? Their income is the same transaction fees that Bitcoin has, except that no one is using it as a currency. It has the name registration fees, which the last time I checked, it's something between 1 and 5 cents to register a name, and it's first come, first serve, and all the names are already taken. And it does merged mining with Bitcoin, and it has the same schedule, and it has even higher inflation than Bitcoin because it's earlier in its distribution schedule. So it's at least 10% per year dilution, which one Namecoin is worth like $10 million. They're spending $1 million of the Namecoin holders' value and doing nothing with it. So the DNS DAC, the first thing is it has extremely cheap security. Proof of work is extremely centralizing and very inefficient, and everyone thinks, or pretty much everyone who I trust thinks that proof of work is dead, and we can't keep building systems using proof of work. But it costs basically nothing to secure the network. And the network income, which in our case, we are for our first domain namespace, we're trying this experimental model for price discovery on names, where we basically throttle the amount of names being sold at once, and then give people kickbacks for getting outbid, basically bidding up undervalued names. We're just gonna, that's like just an experiment. If it starts going really badly, we always have the option to set the throttle to 0 and try something different. But it's just one namespace, and the hypothesis is that this will make people bid. There will be a lot of the distribution of the basically everyone is incentivized to get the names to the right people for the right price, and all that for the part of the for the right price income goes to the speculators who help price domains, but all the rest goes to the network. And what that means is simply people are giving money into a transaction that they aren't expecting out, and they do this anytime they're basically trading it away for a service. And so anytime you can get someone to do that, you can basically think of it as a fee that your DAG has the option to either destroy, which is like a dividend for everyone else that owns the token, or you can choose to direct it via delegates. You can choose to spend it on things that are useful for the owners of the token. So I guess it would be really nice to actually have the DAC launched and compare their incomes and their expenditures. But once you get around this basic concept that anytime you print shares, you're like spending the money of the people who own the coins. Anytime you destroy shares, you're like paying a dividend to all the people that own the token. Yeah. Once you start, once you understand the metaphor once, it becomes pretty obvious. Like, okay, what are the lowest hanging fruit in terms of just profitable blockchains? Like, what are basic services that people really need, that they're willing to pay a lot for, that so far the only way people have come up with how to do them is using blockchain technology. So the DNS stack is a pretty simple one. It's uncensorable namespaces. There's a huge demand for this globally, to just have one namespace that's not censorable. And people will pay a lot for names in this namespace. Or we hope so.
Is there a timeline
for
deployment of Is there a timeline for the deployment of this name DNS chain?
I really don't like saying dates because I always disappoint people. But we have test networks right now that you can participate in that we're claiming this is exactly what the test network will be. Obviously, it's going to be that minus whatever bugs we find. One thing that is kind of holding us back is UI development, and it's actually the thing is, as soon as we launch it, we have all this income. The DAC does, not me, or not Invictus, or not BitShares or anything, but just this. It's like Namecoin has all this income. The DNS stack has all this income that it can spend, like hiring people to write a better UI. So it's like the software hires people for itself. Actually, it's not actually the software. It's sort of this emergent will of the stakeholders in general. But each DAC has a very specific, like the people who own stake in this DAC are doing it because they think it'll go up in value because it'll provide this service well. If they don't think it's going to do it, they're either going to fix it or dump the stock or whatever. So the idea is the incentives are actually better for things where you need services like uncensorable namespaces when you structure it like people are paying for the service and the other people are using that income to maintain the service. Oh, sorry. I think did I just cut out? Can you hear me? Okay. Okay, sorry. Okay. What? Sorry, where were we just now? I can't hear you. I can't hear him.
Can you hear me now?
Yes.
So you were talking about how the emergent will of this group of people in the DAC allows them to make decisions and bring in new programmers, etc. Now that they also have, quote unquote, the money and the tokens to be able to do so.
Right. So that's one perspective. Some people don't agree with that perspective. It's a very like capitalist idea of how you're supposed to do things. You know, the capitalist idea is you just let people compete and they'll build the best, cheapest, efficient thing because they have no. You know, the best thing you could force someone to build would be at best as good as this. Assuming you can initially construct the incentives right, so that the shareholders of the DAC become sort of self-selecting for the same goal. So that's why it should be fairly. That's kind of why we have separate specialized DACs.
Right. I think you're right about the fact that it has to be set up right. And, you know, I guess over time with newer models, we'll all begin to understand what works, what doesn't, and stuff like that.
Yeah. Yeah. The only other perspective I've heard on this is actually if you just are all these like complex governance models where the blockchain is not actually proof of stake and they have some other way of making decisions, but I haven't seen anything useful. Proof of work is definitely not like fair or decentralized or anything.
Right. So this might be a good time to talk about DPoS in some level of detail.
Yeah, so the idea is the network selects the block producers. The only job of a block producer in any of these systems is to create a valid next block. That's it. All the rest is some consensus mechanism that you're trying to come up with. We sort of, again, explicitly embracing this idea that the token holders own stake in this autonomous entity, and they are the ones that should control who the block producers are. They literally just vote on who the block producer should be, but it's voting with your shares. So if you own 51% of the shares, it's effectively your company. And it's very simple. You just have approval voting, which is where every individual has a sort of like a separate election, either yes or no, for each guy. And the top 101, which is just an arbitrary number, but we sort of just went with it until we have more information. The top N people by approval vote get to become delegates, and all they're trusted to do is not produce invalid blocks, which anyone else can check if they produce an invalid block, not to double sign blocks, which anyone else can instantly check if they double signed a block, and not to like exclude transactions selectively, sort of to try to manipulate anything that's going on, which is a little bit harder to detect, but still fairly easy. If the only reason those people are there, and it's a paid role, and the stakeholders are paying for those people to be there and produce the blocks, if anyone detects anything wrong in one of these nodes, they're going to be gone in a minute, maybe not a minute. I don't know how long it takes. We've had like bad delegates hang around for a while, but they can't do any harm, basically. It's sort of like Bitcoin proof of work mining has delegated proof of work, where you have. So first of all, back up. Bitcoin has two types of shareholders. It has shareholders which are the Bitcoins, and shareholders which are the people who own the hash power. So your percentage ownership of this DAC in the controlling sense is what percentage ownership of the hash power you have. So there are some companies or groups of individuals with like 10% each or something like that. But that's like the upper bound. And then you have mining pools, which is where people can delegate the hash power they do have to someone who all they're doing is the exact same thing. They're still just producing the block, but now they have sort of more influence over the process because more people delegated their influence. So in Bitcoin, you have like effectively two or three people producing all the blocks, and if you can coerce like 2 out of 3 of them, or at least the biggest 2 out of the 3, you would be able to at least temporarily control the network. And the people that hold Bitcoin have no recourse against this. They basically rely on the people who do have direct control over the infrastructure to fix it in a way that doesn't screw them over, assuming that this is an obvious attack. But sometimes it could also be not an obvious attack, and you wouldn't know who it is because it's not Bitcoin holders. And they say the definition of Bitcoin is whoever has the most proof of work. So that gives them a lot of power over what's at the end of the day just an informal social consensus. The software helps us enforce the consensus, but when there's a bug in the software, we recognize it as a bug and not as and not as the definition of the protocol. So if Bitcoin was taken over by proof of work, if someone just bought out all the hash power and started doing something malicious with it, it seems pretty obvious that people would not keep calling that exact protocol Bitcoin, and they would fix it somehow, right?
Right.
So there's always interest groups. There's always people with vested interest in the success of the service that this system is providing and hoping to profit off of being able to make the system provide a service well. We just make it all much more explicit.
Okay.
I have a question.
Yeah.
Yes, Greg, go ahead.
I'm looking at the wiki for delegated proof of stake, and I don't quite understand the role of the random number generation stuff. I don't understand how many people are responsible for producing a block. It's in one section it says in each round, all 101 delegates build one and only one block. So it sounds like there are 101 entities making one block, but that's confusing to me. I don't really understand what that means. Who is ultimately responsible for the block that gets accepted by the network? Is it all of them? And if so, how does that work? Or is it just one of them? And then what is the role of the random number?
Okay. I'll get to the random number in a second. It's basically all 101 delegates go in turn at the end of each round. At the beginning of each round, they find out the order. They all try to do it in order. And if someone misses a block or produces an invalid block, the next guy just ignores it. And if he misses a block, then the next guy, picks which, or basically at every point you have, if the current guy is honest, he can resolve a fork and he can produce a valid block based off of a one sometime in the past based on these missed blocks. And basically, because you have 101, you're always going to have a longest chain in each round. You can see if your participation drops from like 10 to 90, or from 100 to 90, you could be like, okay, probably some delegates crashed. If you go from 100 to 30, you're on a minority fork, and you look up and you're like, hey, did we get disconnected? What's going on? But you can always from each delegate going on his turn, you can always, after one round, know what is the current hypothesized longest chain, and then know how long until it is effectively confirmed.
Can you explain what these rounds are? I'm missing some context here. What are these rounds that you're talking about?
A round is just 101 delegates go. They
go where? What do they do?
Where the guy number 0 produces a block, guy number 1 produces a block, guy number 2, etc. Until guy number 100 or 101 produces a block. And then they use this random number scheme, which I'll get to in a minute. But basically, they have a good random number at this point, and so they all know the order they need to go in next. So they're going to go 101 again, but it might be guy number 51, guy number 2, guy number 60, guy number 70.
Well, when you say they produce a block, is this block being broadcast out to the entire network, or?
Yeah.
Okay, so what is involved in a round? Is it how many blocks are produced in a round?
It's the number of the same as the number of delegates that there are. So 101 in our case now, at the moment.
And how often are these blocks being produced?
Every 10 seconds.
So every 10 seconds, a new block is being broadcast out to the network.
Yes.
Isn't that a lot of blocks?
Yeah.
Aren't you going to have scalability issues?
Not going to be much. I mean, the block headers are tiny. If you have an empty block, it doesn't matter. If you're going to have at least the same scalability issues that any other system has when you actually start counting what matters, which is how many transactions are in there.
Well, what are you saying, that the headers are like an order of magnitude smaller than bitcoins?
No, that the headers are an order of magnitude smaller than the transaction volume we hope to get. And that it's going to be a competition of how you're able to handle this much transaction volume to begin with.
All right, and I'm guessing you guys did the math and you decided that even with empty blocks, you know, per year, it's still not too much data being generated?
Yeah.
At every 10 seconds?
Yeah.
Okay.
It's also really easy to compress, like, okay, I had 1,000 empty blocks, just come up with a scheme for
Okay.
that's old enough to compress it.
And then, so what does the random number do?
So the random number is basically at the end of each round, you need to have a good source of randomness for determining the order of the next round. Otherwise...
What do you mean with the order of the next round? Who goes first, or what do you mean?
Yeah, who goes first, who goes second, who's supposed to go third, who's supposed to go fourth. So that's one round. And to determine that order, you need a good random number. And what we do is this sort of commit and reveal scheme where to produce a valid block, you have to reveal the secret that you committed to in your previous valid block, and then all these secrets are hashed together. So basically, as long as even one delegate is honest, no delegate can predict what the order of the next round is going to be, and this helps prevent some manipulations. But it's also useful because some services rely on having a random number generator. Like a game is the easiest example, like just a basic like heads or tails betting or something.
Okay, and so the delegates themselves are. So what is the? I saw you have votes there. There's voting, but then there's also stake. So can you elaborate on who the delegates are and how they are chosen based on votes and stake? What is the relationship between votes and stake?
One token gets one vote. So it's stake vote.
So that's a question I also have. How do all the other participants in the network actually vote for these 101 delegates?
So the balances you control basically indicate which delegates that balance is voting for. So each token has one vote power, and you can vote for 101. So it's approval voting. You can say thumbs up on up to 101 different people.
You mean 101 different addresses?
Different like names in the namespace. They could be the same person or the same entity.
Right. And is there anything? Is there a rule to prevent people from voting for their own address to nominate themselves?
No, you can vote for yourself.
Okay.
I mean, it's basically like it helps to wrap your head around approval voting. Like the largest stakeholder probably has 10% or something. This is just the hypothetical, and the approval voting would be the approval, like smallest approval would be like 60% or something.
So how do you guys prevent forks?
Well, just every single delegate tries to not make a fork, and if a delegate either misses a block or produces a double block or makes an invalid block, any of those, you just ignore him. And so if you have a fork after one round, or maybe you do after a couple rounds, you can see what proportion of the delegates are on your fork.
So can you explain how a fork could happen? What sorts of situations can lead to a fork?
Yeah, a delegate can sign 2 blocks. So, like, it's his turn. It's supposed to be time slot, block number, whatever. It's your turn. And on his turn, he makes 2 and broadcasts them to different parts of the network. He can fail to produce his block, and then when it's the next person's turn, like they would have skipped him by now already, he can produce it late. And so the next guy isn't sure which one is the real thing, except in that case, that's actually one of the easier cases because you just pick the later one. They could produce a block that some people think is valid and some people think is invalid. Like if there's a bug, like in the software, and it's just kind of like, half the people updated, and their client says that you're allowed to print 1 billion new shares by doing this operation because like some overflow or something. They'll be on a fork, and then everyone will be like, okay, guys, you have to downgrade your software. Assuming, okay. So at the end of the day, it's like whichever chain has the most delegate participation, and where you just exclude everyone who double produce.
Okay, and what would a 51% attacker be able to do on your blockchain?
So 51% attack has, again, because of approval voting, what do you actually, 51% of what? If you just buy 51% of the company, you effectively own the company. You can't, there's no consensus model where you can get around 51% is actually 100%. So what it's more like is either you buy out enough of the company that your approval is like bigger than everyone else who's active put together, and then you can do whatever you want. Or if you don't have 51% of the stake, it's possible for everyone else for you to have 0 control.
Well, you said do whatever you want. No, I want specifics because, for example, in Bitcoin, even if somebody has 51%, they can't do whatever they want. There are some things they cannot do still. They cannot, for example, take funds from somebody who's...
So the network freezes, basically.
The network freezes?
Just like in Bitcoin, that's effectively what happens. If you have 90% of the hash power drop off the network, that chain that's still there, people aren't going to switch to that and be like, this is the real Bitcoin now. Because you don't know what will happen as soon as the other ones turn back. Probably at that point, it's like, oh crap, it's an attack. We need to change our consensus mechanism. And the point where the attack happened is where we're going to branch off.
Well, I mean, in Bitcoin, they've analyzed what a 51% attacker can do, and they, post there are various, lists on wikis and on individual sites that clearly state, a 51% attacker. Like one number that's thrown around frequently I've seen is they can reverse transactions that are 6 blocks deep. I don't know if that's accurate or not, but suppose
arbitrarily far in the past when they're 51. 51% is like 100%.
I don't think
they can't forge a fake blockchain, right? But I'm just saying, what I could say is, yes, Bitcoin miners can't empty your balance, and Bitcoin miners can't send your funds to anyone without your permission. List off things like that. But effectively, all you're saying is, when someone takes control of the consensus protocol, you freeze the network at a particular point conceptually, and say this is where the attack started and did the undesirable thing. And this is the new non-hacking thing. So a
51% attacker on Bitcoin and a 51% attacker on delegated proof of stake. What I would like to know, are they the same in terms of capabilities, or are their capabilities different?
They're the same thing.
And what I might add is, maybe if there are some links to this that we could sort of actually take this offline, the real depth of it. But it'll be valuable to know, as Greg pointed out, is 51% in effect 100%? I think that's what you said. And I think the detail of it, specifically exactly what they can do, is there a document on that someplace?
Yeah, I mean, you can. The wiki's not great, but basically the best documentation is the DPoS article on our wiki, which it's enough to infer everything, but it's not very clear about all the different consequences of everything. But if I were to summarize, I would say that a 51% in any network, the worst it can do is freeze the network until the real, quote, owners can figure out how to change the consensus mechanism so that the, quote, attacking person doesn't have control over their consensus mechanism. They can proceed from the point before they were attacked. So in DPoS, that's a much more exaggerated difference. If the top 51% of stake are sort of not doing anything that's, quote, an attack, then there's nothing an attacker can do. There's 0%, a 51% attack, or even like a 30% attack where you just sometimes can get 2 blocks in a row if you're not mining on the main chain. Stuff like that is impossible to do. An attacker can do much less for anywhere up to actually owning the network, which is owning more than half the network. And at that point, the two perspectives are: one, they can do whatever they want if you keep participating in their network, or two, the network is frozen until people can fix the consensus mechanism and get control back. So you basically split into two DACs. One has these rules, one has these rules, and they both start at this point where the attacker got control.
Does that answer the question, Greg?
Maybe a little bit. I think a complete answer would be sort of what you mentioned in an in-depth document that discusses this, maybe like a blog post or a dedicated wiki entry. Yeah, and I probably have some follow-up questions, but I need to think about how to formulate them well.
Okay.
Maybe the next.
No.
Okay, there's a question here, then we go to another topic.
Can I ask some question about?
This is Solomon, by the way. Just give a one-liner.
Hello, hi, Nikolai. Hi, good way to meet you. So actually the voice here, right, is kind of choppy here, so that I didn't hear a lot of it. It's
the audio is not very good.
Audio is like, yeah. So I was wondering about a few things. One is like, so you were mentioning that each token is 1 vote. Is that correct? So if someone has like 10% of a token, he will have 10% of the vote to vote for the delegate. Is that correct assumption?
Yeah. Right.
Okay.
Yeah. And then remember, it's approval voting. So if they have 10%, and all the delegates currently have more than 20%, they have zero control over who the delegates are, even though they have 10% of the stake. On the other hand, if half of them have 15 and half of them have, or if half of them have 20 and half of them have 5, he can vote in as many delegates as there are people who have 5, but he can't vote up people who have 20. So someone who has approval from a lot of different interest groups is going to be closer to the top than just one person who has a lot of stake.
So the top 101 delegates who has the most votes are the other delegates that will produce the blocks.
Yeah.
And then the blocks are, so among these among these delegates, right? How do you decide which who will be producing a block at that each round?
Yeah, there's just a fixed order. Every 101 blocks, you use this random numbers generator scheme that we have to shuffle the delegates up, but it's deterministic, so everyone knows when they're supposed to go in the next round, and it's just intervals of 10 seconds. So one assumption in this network is that at least the delegates can be synced. Their time can be their clocks can be synced up in order to produce blocks 10 seconds apart.
And then each time, each time. So and then each time that they produce if one of them fail to produce a block, you just skip to the next round, or you skip to the next delegate.
You skip to the next delegate.
Skip to the next delegate, but producing the same round, the next block.
Yeah, the second delegate still produces his time, not the one that was missed.
And does voting happen every round, or is it continuous, or how does that?
How often does what happen? Voting?
Yes.
Yeah, voting is continuous. So every time you do a transaction, you can update the votes on a balance by like moving it, right?
Mm-hmm.
Updating the votes and transferring it to yourself are like equivalent operations. So every once in it's continuous, but in practice it's like every once in a while I'll update my vote list and send all the funds that I got in the last couple of days back to myself. But it's effectively continuous. Like if there was an emergency, you could get everyone, in theory, in 10 seconds. But
so as a topic, as a next topic, I'd like to understand the concept of the BitShares source code is meant to fork and build multiple blockchains, but there's this concept of a 10% participation. If you could help us understand that a bit better, how that sort of works. I mean, that the original BitShares or BGS owners have some sort of stake in the new blockchain. I mean, could you elaborate on that?
Yeah, so the original, like, I guess, funding model for the ecosystem and distribution model was, well, part of what makes a DAC successful is having the right initial stakeholders. We don't want to get into the business of selling anything or making a centralized company that manages these, which would have, I don't know, we wanted to avoid all that and say, okay, we're just going to make a normal cryptocurrency that people mine called ProtoShares. It's just a Bitcoin clone with some tweaks, like a different proof of work algorithm, but it's effectively the exact same thing. Mm-hmm. And people who have interest in these sort of projects can mine PTS, and at least 10% of all the DACs that at least we build will honor holders of PTS. And because of this incentive, we also hope that a lot of other DACs, if they want sort of like if they want to distribute their stake among people who they think are supportive of the ecosystem and supported it early and speculated on this idea, you're the initial distribution of the stake in your DAC. You can give part of it to them. So like for the DNS, the same idea is kind of for the DNS DAC. We were originally going to give a percentage of the ownership to people who had Namecoin, sort of to like you figured, hey, if we don't do this, someone might make a clone of our software, but initializes it initially to Namecoin. Maybe that network effect could jumpstart them and take them farther. So it's in our interest to like honor existing like groups or collections of stakeholders in the ecosystem. So we're specifically launching this one, ProtoShares, that we're all sort of going to band around and make this the proto DAC that you should buy if you just want stake in future DACs. And sort of like, it's popular because lots of DACs use it, lots of DACs use it because it's a good mailing list that's popular. So we had that, and then realized people were spending hundreds of thousands of dollars on like Amazon cloud miners to mine PTS because they had interest in this. So they made a second similar thing, which the initial BitShares people and first couple of people building DACs said, okay, we'll also honor this thing for 10%, and because of that, it's a good mailing list, and because it's a good mailing list, hopefully more people in the future will also honor this group, and so this 10% goes to people, is allocated in proportion to how much people donated to a nonprofit trust, which basically funds all this development. It's sort of like the Ethereum crowd sale, but slightly different mechanics. That's not held by BitShares. There is no BitShares organization. It's not held by Invictus.
Mm-hmm.
It's held by some trust in Hong Kong, actually.
Yeah.
And so you're not buying any of our shares in any of our DACs. You donated for the original development, and people can choose, anyone, including us, but anyone can choose to honor AGS holders or honor PTS holders in the initial distribution as a sort of strategy for getting network effect and getting supporters who know what they're doing and stuff like that.
Got it. Two things. One is that the audio is better, so whatever you're doing now is working. Thank you.
Okay.
The second thing is that if I had to summarize what you just said, is that people can take your existing blockchain, fork it, and if they would like to take advantage of the network effects that existing members of holders of ProtoShares, or BitShares could offer, they could then incentivize them with a suggested 10% offer. Is that sort of accurate?
Yeah. They published. They wrote out what they call the social consensus. They just declared it to be that everyone should be really happy if any DAC gives 10% to each. But that's not a requirement. There have been DACs that gave 1% to each, and everyone sort of collectively shunned them in our community.
Okay.
And then the DNS DAC and the BitShares X both have a lot more than 10%, and we expect there to be everything in between, and 10% is sort of like an arbitrary. We semi-officially, even though we're not an organization, we'll endorse it.
Okay, I think that clarifies it. Could I then move to another topic, which is, can you tell me all of the? I've talked to a few people, and everybody says they're confused. What are all these different BitShares thingies? There's X, there's music. I mean, it just is like, could you maybe help us out there? What are the family of BitShares? What you currently have? What does each of these different bits do? And what are your plans for them? I guess.
Right. So BitShares is sort of a brand name for all the different DACs. So I already told you about PTS. AGS isn't technically a DAC, but it's still like a thing you can have. So BitShares, AGS. Then there's BitShares X, which is sort of the flagship DAC, which I actually haven't talked about yet. It might be good to talk about. And those are the only things that are actually out there. Oh, there's also a third-party DAC. Again, everyone's sort of a third party, but this guy is just not working with us at all. He's just somewhere out on the internet. Lotto Shares DAC. It's not explicitly branded BitShares. I think he just chose not to, but that's sort of one of our DACs.
Did he give you 10? Did he give 10% of the holders of AGS and PT? Okay.
Right. Yeah. Then there's DNS, which is launching soon. We're testing now, and it's basically just a trade-off of launching sooner versus having better user experience. Then there's a couple more in the pipeline, but they're not really under active development. They're DAC ideas. They're sort of other low-hanging fruit in the decentralized.
Would music be one of them? The DAC music.
What?
Music.
Yeah, that's in the pipeline, but I don't want to talk about it too much.
Okay.
There's not enough done for it.
Let's get into BitShares X. That's your flagship DAC. That's the one that's presumably live as we speak. So what does it do? What is it all about?
So it's just another altcoin, just another crypto 2.0 project. But the best way to explain it is using the DAC metaphor. The best analogous centralized company would be a bank or an exchange. This DAC basically makes derivative financial assets, which based on itself, using its shares as the real source of value. So, for example, if you lend something out, you use BitShares X as the collateral. Well, you trade things against it for user-issued assets. But basically, it's an altcoin that lets you hold value in different assets, which are either one they're market pegged, so the DAC basically lends out dollars on collateral, and you can hold $1's worth of the shares, or an ounce of gold's worth of the shares, instead of actually being exposed to the volatility.
Would you say that's like XRP that Ripple offers? Is that
No, it's different in a very important way. Ripple, all of the tokens, they're all IOUs from individuals or from organizations. So they're securities, basically. Someone is promising you dollars in exchange for this note. In BitShares X, all the bid assets, we call them bid assets, or the market pegged assets, or the price tracking assets, they are created not by an individual making an in real life promise like a IOU, but instead the network is printing BitUSD out of nothing, but they are backed by the collateral that someone is putting down. So you have so a BitUSD is basically the person who wants the stability in a contract for a difference against BitShares X.
Mm-hmm.
And so the network can lend out BitUSD. I can short sell BitUSD, and then someone can hold it just because they want the price stability of $1.
Mm-hmm.
And then someone else can use it to get leverage or make more complex financial instruments out of it.
So BitUSD is a synthetic instrument based upon a BitShares price, and the peg is based upon some conversion rate, but it's always be 1 BitUSD. So you could sort of hold 1 BitUSD regardless of how many BitShares it actually sort of.
Yeah, and there's lots of nuances and caveats, and I don't want to go into it too much, but that's the idea. That's the product we're trying to make, is someone can hold a crypto asset that has stable value.
Okay.
But the other things you can do on the platform are also the same user-issued assets that you have on all the other Crypto 2.0 projects, like Counterparty or whatever. You can lend or not lend, you can just issue an asset and say, this represents so-and-so, I promise. We're actually working to make our system so that if you want to, you can make a regulatory compliant. You can issue crypto equity. You can issue the stocks in your company and have it comply with all the regulations, where you have to know you can only sell to approved people. There's all sorts of rules, but we can help companies enforce those, even within the framework we have, where everything is private by default, and you don't. We use stealth addresses to make it basically as private as Bitcoin is, with best practices.
Okay.
Would it be okay to ask some follow-up questions on the delegated proof of stake?
Sure.
All right. So I have a few questions here. Here's the first one. Are the delegates rewarded for their work? Do they, for every block that they mint, get some kind of coins or whatever you guys call them?
Yeah. They get they set their own pay rate between 0 and 100%, and whatever they don't use is destroyed. So it's like the dividends back to shareholders. And whatever they keep for themselves, they can spend on whatever. Usually, it's because they're voted in, they're approved as a delegate because they said they would spend this on a particular thing.
So they set a rate, right? That they say, this is going to be my rate for doing this work.
Yep.
Who pays that?
It's the income from the network, the transaction fees and the other types of income.
What if there aren't enough transaction fees to cover their rate?
It's a percent of the income.
Oh, it's a percent of the transaction.
0 to 100% of the accumulated fees pool, which is like you draw out of it at like 1/100th every block.
Okay. Well, so this brings. I think my biggest concern is involving this question. Even though I do have other questions. But I just want to point out that if this is the case, we have to look at what has happened in terms of wealth distribution in various other financial systems, in both our existing financial system, like in the United States, and in the stakeholders of Bitcoin. And what we see is that there's extreme inequality. In fact, I think in Bitcoin it's actually even more exaggerated than in the United States. Like a smaller fraction of the owners of Bitcoin own most of the Bitcoin that's out there than in the United States. And in the United States, I'm sure most have by now seen the graphs of how it's like 1% of 1% owns some astronomical number. So if you're doing a fixed constant of delegates who are voting, which is 101 delegates out of potentially.
They're not the only ones voting. They're the only ones producing blocks.
Right. The ones who are producing blocks, and at a potentially maybe thousands or millions of participants if you guys get successful. It's possible for 1% of 1% of this of 1% of the actual participants in the network to be the delegates, and it's possible that maybe one or two individuals could end up owning all of the delegates, acting as all of them. And if it's the case that the delegates are paid for their work, it seems like another classic case of the rich getting richer, where the delegates are making the decisions and they're controlling the blockchain, and they're also being paid more and more for this work that they're doing. Well, so how do you guys address that concern?
Yeah, so the second part, where the delegates don't choose how much delegates get paid, and delegates don't choose how much shareholders get paid in proportion to their shares. The shareholders pick that. Indirectly, they pick it by only voting in delegates that have low pay rate, but the delegates don't control that. So you still have so going back to the first point you made, which is right, which is what if someone has most of the shares? And again, our perspective is just if someone owns most of the shares, either it's someone bought out the network, or it's an attack, or it's something unclear in between, and depending on where it is on that spectrum, it's either, they just legitimately bought out the network, or it splits into two DACs, where in the second one they say, okay, thanks for buying us out, now we're going to proceed without you. So I guess what are you really asking? What if someone buys out the network and then does worse with it, or then does something like then they basically destroy the network? Hopefully there's other competing DACs. And
well, I think you know my point, because we've somewhat discussed this before, which is that I don't see much point in working on a system that has in its limit case the starting point, which is our current situation, where there's like the Federal Reserve and the Treasury and the government mints prints bills, and then they control the financial system as well.
You can't make competing governments.
So let me be the arbiter here. I'd say that I agree with you, Greg, that the current system has flaws. I also agree with you that BitShares doesn't really, quote-unquote, solve. Yet, BitShares provides, shall we say, an automated method, which is a little better. Say, take Google. Google founders have voting rights, and those voting rights, new investors may not even have those voting rights. Whereas in a BitShares-like environment, owning the shares gives you voting rights. So that's one step ahead of, shall we say, the existing security system for public companies. So I agree they're not solving the problem of capitalism, but they're just making it incrementally better.
Well, in Google, actually, I don't know. I might have to object there, because in Google, like in most companies, we have at the very least this concept of identity, and you don't have that in a computer network where everything is opaque. In the Google board of directors, for example, people sit at a table and you have the situation where you have one human, one vote, whereas you don't have that situation with one of these DACs. You can have a very wealthy shareholder owning all of the 101
No, I was
delegate
talking about
positions.
restricted shares, right? There are restricted shares that don't have votes. And so typically founders, when they bring in large investors, might bring them in with restricted voting rights.
Right,
So
but even there, it's somewhat better because those restricted shares are tied to individuals, to driver's license cards, to proofs of identity that these actually belong to individuals. There doesn't seem to be anything along those lines here.
fair enough. But yeah, so, I don't think they're claiming to solve capitalism. I think they're basically coming up with a DAC. But I think you're right. I think there are those issues to be thought through a little more in detail as to if there could be ways in which we could use the DAC concept to truly sort of bring about some more equality between the wealth, the rich getting richer kind of thing.
All right, well, a second question relates to the 10-second block generation time. It's somewhat less political and just more technical. So you have this DAC, and it's generating blocks. I think you said every 10 seconds. For me, that's somewhat of a concern in terms of just the consistency of the whole network. Have you actually ran real-world type simulations, or at least simulations that accurately approximate what will happen in the real world when you have delegates? Let's say that you don't have one delegate who controls the entire network. Let's say you actually have 101 individuals, and every one of those 101 individuals, or most of them, are equidistant on the planet's surface. And then some of them have congested, connections, and connections that occasionally will drop packets and things along those lines, and all of that really happens in the world. You've got blocks that are generated every 10 seconds. In other words, a new delegate must generate a block every 10 seconds and send it out to the network, and this just kind of goes on and on and on. What will that actually result in a functioning system, or will that result in a non-functioning system, something along the lines of chaos, many different forks going on, maybe 100 different versions of reality that nobody can agree on? How do you know that you'll actually get a consistent picture?
Well, you can have network disruptions in the form of, half your delegates are offline or something, right? Or even imagine like all 101 delegates, they found out their real computers and they just took them down in real life. The network would just stop, right? And it's sort of a gradient between every single delegate is experiencing huge problems to most of the delegates can pretty much talk to each other and a couple are dropping out. The important part is that you can always tell you're either on the longest chain at the moment or you're not. And you can't, if you're on the longest chain, you know that's the real state of the system. If you're not on the longest chain, you know that you shouldn't be trusting what you see, and you should figure out why your network is split.
Well,
it's not different from Bitcoin. It's just sped up. It's just faster.
But that is an issue. I mean, there's an issue. There's a reason, rather, I should say, why Bitcoin decided upon. I think it was a 10-minute block generation delay. Because of network latencies. It cannot really realistically support a faster block generation time. So in this case, we might have, let's say, 5 groups on the planet, and each one of those groups, sees that it's on the longest chain, but each one of those groups sees a different longest chain. Is that possible, and how do you resolve that?
Someone will always be able to tell if they're not on the current longest chain. The only way you can tell is if a delegate is, a majority of delegates have disconnected you airtight from the internet, and they have you on their own private network and feed you a fake blockchain in collusion. The majority.
But given a 10-second latency, and if you have a node, sort of say that has some sort of noise in the line that is unable to sort of understand the current state of the network, wouldn't Greg's point be valid at that point? Because the latency is only 10 seconds.
Sorry, can you repeat that? Someone?
You said 10 seconds was essentially the time for each block. So what if one of the delegates was actually at some sort of a node, and that shall we say, that had some network latency issues?
So they're blocked 10 seconds late, for example?
Wouldn't Greg's point be valid at that stage, because they would now see a different block height than the others?
Yeah, so you would have two. You'd have a network, and you have one side where, let's see, both sides have A. One side skipped B and went straight to C, and the other side has B but has no C. So the next guy in line just picks one. The rule is first pick the longer one, then pick the one with the later delegate. So at this point, either D also has to be having network problems or not. But then when you get to E, you have to wait for 2 blocks to be sure instead of 1 block. But the point is that because there's 101 delegates and you can't sign out of turn, you'll know by the end of a few rounds, or not even the end of a few rounds, by the end of you'll know by the end of 101 starting from now.
But it would be out of turn because the random number is different in the 2 chains. So you'd have 2 different turns, in other words.
Yeah. Wait, you mean 2 different shuffles?
Okay, so one block chain says this is going to be the order of the delegates because I have this random number that I generated, and then the other blockchain has a completely different one. So the order also would be, you'd suddenly have 2 different orders to go.
The problem happens on the last delegate, right? Because that's the random number.
It ends up being equivalent. It's all the same. It's the same as if you can still just think of them as A, B, C, and D.
Right. Okay, but I still don't see how this issue is resolved.
Like in the next round, you'll basically have one fork where the guy they shuffled and they got this order, and the other fork where they shuffled and they got this order. But at the end of the day, you're still going to have by the end of your round, one is going to have more delegates, or you might have to wait. Actually, if you started mid-round and shuffled, you would have to wait 2 rounds. Or
let's make it more extreme. Let's imagine the world got split into 2, and like a pie chart. The right side of the pie chart is working on one order and one chain, and then the other side of the pie chart is working on a completely different order in a different chain. And for whatever reason, these 2 slices of the pie are kept out of communication for a period of time.
So they have different shuffles now.
Yeah, they have completely different chains, and at some point in the future, they suddenly see each other, and so they see 2 completely different chains that are basically the same length. Let's say they're both of length 35. I mean, what do they do in that situation? Do they just basically throw their hands up in the air, or what? And how do the other people participating in the network decide which chain to go with? And is the situation ever resolved? I mean, if they pick randomly or the first one that they see, they could just perpetuate this fork into perpetuity.
No, it all resolves.
How?
So, first of all, in the example where you have a split network and the networks the round is shuffled, they have different shuffle in both networks. As soon as you've gone longer than 1 round in this new shuffle, you know whether you're on a majority fork or not. And in the case where this happens temporarily, they both have just few enough delegates that they don't know whether they're the majority fork or not, and then they have exactly the same number of blocks in each, and then they reconnect and they can start talking to each other. The next delegate just follows the same rule as always. The one that's longer, if there's a longer one, if they're the same length, the one with the more recent block, and if they have 2 that are basically the same metric, he can pick randomly if he wants, as long as he doesn't also perpetuate the fork by signing 2 blocks.
Have you guys done any simulation along these lines?
Yeah, we all sort of run a network, split it, have them go separately, recombine it, that sort of stuff.
That was my question. On your forums, you actually talk about these stress tests. Could you go into a little bit of detail? Like, you have, I guess, number 8, number 9, and you go different. You have the sequence of stress tests. Could you sort of talk about that?
Yeah, the stress tests the stress tests on the forum we were testing how many transactions per second we can do.
Okay.
And right now, very deliberately keeping everything very conservative, we just picked 10 transactions per second just because it was more than Bitcoin. It was just some arbitrary round number more than Bitcoin that we can claim we're faster, and then capped it there on purpose it works with together with our strategies for like anti-spam and stuff. But the idea is that this architecture should let you do a couple thousand transactions per second, so actually do like on the scale of real payment processors. But right now, yeah, our stress tests, we're just hammering the network continuously with transactions. We were generating them much faster than 10 transactions per second. It's just the network.
What is the nature of your simulation? Because if you're excluding some real-world network latency effects, then it might not be an accurate simulation. So do you have some kind of really complicated model for modeling real-world network latency effects with packets either dropping completely or going out of order, and all of those kinds of things?
No, we have done tests on real networks, but the model we're going off of, you can just assume that the networks are arbitrarily bad. You can do whatever, simulate whatever bad behavior you want, and just think at the consensus level, like at the protocol level, the order of the different blocks. And the rule is always that the rule is always that as long as you have at least 51 honest delegates, you can always tell if you're on the right chain, and when the network, and you can always tell when you're not on the right chain.
Okay, so what tells you if you're on the right chain?
It's whether you've had more than 51% delegate participation in the last round.
In the last round.
Last full round.
Last full round. So do you mean the last 101 rounds?
No.
I thought you said a block was generated every round by one delegate that was chosen at random. So
101 delegates in each round.
Which will be 1,000 seconds.
Yeah.
Approximately 1,000 seconds.
Yes.
Wait, 101 delegates in every round?
So the word, yes. And
10 seconds a block. 101 under 10 is like about 10,000 seconds for one whole round. And so at every 10,000 seconds, there's some sort of a reconciliation that happens.
It's not necessarily reconciliation. It's you're not on the true state. That's not a reconciliation if you're on the minority fork, but it tells you that there's problems. Yeah, but then also, so it's like compared to Bitcoin, their worst case, quote unquote, it's not continuous. It's not discrete in their case. It's just you get more and more certain. They say like 6 blocks is you can be sure, and then one block can take you up, like 10 minutes on average. In our system, the worst case is however long a round is, or whatever, 1,000 seconds, and the best case is usually it's 10 seconds, but also it provides you much more security on average for the first block, because there's barely ever any orphan blocks in DPoS. If there's an orphan block, that basically means someone is double producing, which is considered a bug or an attack, and so it gets fixed.
Didn't you say that the person that makes the block was chosen by a random number?
No, the sequence was chosen by random.
Sequence, yeah.
What do you mean the sequence?
The order in which they are going to sign the blocks in this round.
So they go round by round, 101 per round. The next 101, the sequence of the 101 is a random number generated sequence.
Oh, okay. And each delegate, based on their place in the sequence, does what? They sign the block?
They produce a block. Produce and sign a block.
No. But you said only one block is produced per round, and there's 100.
101 blocks are produced every round.
Oh, okay. Well, that's completely different from what I remember. Okay, so 101 blocks are produced per round, and the order in which they are done is determined by this random number.
That's right.
Okay.
So let me take it to a different point, different topic, right? So we kind of now have an understanding of how the DPoS system works. We have an understanding of, we may not agree that is the right one, but we have an understanding of how the delegate sort of 51% attack could either be 100% or not. We have an understanding of your 10% shares, how they're allocated across these new DACs that are formed. Can I ask you from a BitShares or Invictus perspective? What's your vision? I mean, what would you like to see happen? We've got a group of hardcore developers here. What advice would you give them and say, hey, look at BitShares. You can do these things with it. So what's your vision for the company Invictus, or the adoption of BitShares, for the multiplicity of DACs? Can you give us 5 ideas for DACs that you guys have thrown around? Things like that.
Yeah. Well, I guess the high-level goal is to significantly improve how some functions in our society work by forcing them onto these secure, transparent public ledgers. Dan is all about how it promotes freedom, and he's all about using these technologies to make more aspects of society voluntary and to replace, make irrelevant certain current power players. But it's a new competitive advantage over companies and existing companies and existing some functions of government. And people will flock to it voluntarily just because it's more honest, more open. You can see how everything works. You're not getting ripped off. You sort of know who's in control when it matters, in the situations where it matters, and you don't in situations where it doesn't matter. I could go on just make a big list of idealistic or driving ideals, I guess. So that's the vision, and I guess the steps along the way are just keep building DACs, keep testing different applications of this.
So to the engineers in our room, what would you say to them, developers in our room? What could they do with it? I mean, can you give us 5 ideas that you guys have thought about that could be valuable to sort of use your platform for, that you guys don't really have the bandwidth for right now? I mean,
well, yeah. Instead of telling everyone all our ideas and saying, okay, go make these, another option is there anyone that is looking for work? Because we're actively hiring.
We put it out on the list. We let people know. I mean, yes, there are people who are looking for maybe not full-time work, but projects who have got some skills. Yes, we would let them know. Yes.
Okay. Yeah. Yeah. So we have a bunch of DACs in the pipeline, and it's becoming easier and easier for us to bring devs on board and pay them part-time in crypto. After first it's all these donations come in, and you can start paying people with that. But then these DACs come out, and then part of the snapshot goes to is in the trust, so we can pay people with that. And now these DACs are coming out, and delegate roles also can pay people for development. And so basically, your options are, if you want to get involved, find an existing DAC and just get involved. Just directly contact anyone you can find who's related to it, and just try to work your way in. And then if you have ideas for DACs, we will also be really support you. Also, come directly to us, and we'll help you do it. Again, at this point, more likely we'll just be like, okay, no, come work for us, help us finish these. But just because we think it'll be easier to get more DACs through the pipeline if we're all working together. But you don't have to. You can just say, hey, I want to use your software. Can you provide some basic support? And to the extent that we think it'll be a successful DAC, or any one of us individuals thinks it's worth our time, considering we're all at least partially invested in AGS and PTS. So if you can sort of join the movement just by honoring the consensus. And we have a couple of, so right the position is now in the realm of ideas, good DAC ideas that we know are good, but we're not doing right now. We have teams sort of set up and starting on all those already. I can tell you about some applications of the blockchain, but it wouldn't be like here's how I think you should. I don't know. Everything that's low-hanging fruit we're doing already. Everything that's not, we're sort of putting off and assembling groups for.
So what are some of these applications of the blockchain that you currently got some groups for that you're working on? Is that public? If so, could you tell us? If not, it's all right.
So let me think. So there's a music DAC which I'm not supposed to talk about. They just asked me to. Again, it's not like company policy or anything.
Okay.
And then let's see. There's a gaming platform DAC which basically will expose the random number generator and eventually, hopefully, just embed a whole scripting environment in there for people to make games. Basically, like gambling, like the lottery, and then those dice games that people really like with Bitcoin.
Okay.
I'm not doing that one, but someone else is handling that, just because that's such low hanging fruit and like such guaranteed. Like we have numbers about how much like basic dice websites are making, right? Like let's just do it right now. So someone is doing that. There's someone doing a few different variations on like prediction markets and betting markets. There's like a fantasy sports one. There's the Truthcoin guys were talking with us for a little bit, but we are a little too busy to help them too much right now. But that's prediction markets on a blockchain. We have some talks from Dan where he describes concepts for an insurance DAC. Let's see, I already mentioned DNS, we already talked about DNS here. BitShares X has a lot of potential variations, so if we figure out these sort of how to create basic financial instruments like a dollar on a blockchain, I imagine the BitShares X will become like a whole family, honoring BitShares X and forking it and changing things. Sort of like Bitcoin in the altcoin space, except here when you're competing, you actually have more things to compete on rather than just like your name and brand identity in the altcoin space.
Okay.
A question on so I was just reading the vision page, and then on your vision page, it said that try to create an information network where like you can pay people for contribute to the information like music or something else. I wasn't sure that how exactly that could be done or be done. Like how exactly you are paying people to like for the information contribution, etc.
So, well, basically anytime you interact with a DAC and make money off of it, that's an information-based job. That's the only way a DAC can give out or take in values in the form of adjusting some ledgers according to some certain rules. So they're all information-based jobs. And so examples of how to think of why it gives lots of people an opportunity to contribute and profit is like, the mechanism for like how BitUSD works and the BitShares X stack. If you're a trader and you understand all this stuff, then it's you, the traders competing in this market, that the emergent effect is that you've created this stable crypto asset. Or, for example, in the DNS stack, with the auction incentives where you can sometimes get paid if you get outbid, you can profit by bidding on undervalued names. And that's sort of you're helping allocate resources effectively and you're getting a kickback for it. In music, the idea, the high-level idea is you can own shares in a song instead of copies of a song. So if you are really into music and you know that some artist is going to be successful, you can help fund them and also profit from their success by being supportive early on. Which is what all fans want to do that. All musicians want to be able to do that. Yeah, so none of these, all these DACs are all just rearranging things among the people that use them. They're all just people exchanging involuntary trades in one way or another. And so anytime the DAC can pay you to improve that, that's you getting paid for an information-based job.
So you were saying that, so back to the example for the financial instrument, right? How does that work for the financial instrument?
So the BitUSD is created when basically there's a speculative market over the relative directions of.
Just a question. Does BitUSD exist currently through the BitShares X sort of service?
Yeah.
Okay.
And tagging on to that, how is the market peg held up? Is it trading at par or at a discount, or what's it look like?
It was trading at a discount, and we're introducing some restrictions based on price feeds, basically.
So I can go to BitShares X today and buy BitUSD.
Yeah. You can also buy BitUSD on some external exchanges and treat it just like a cryptocurrency. You don't have to buy it through the.
Are you the first guys to do this USD pegged coin kind of thing?
I think so. Yeah. That's how this whole thing got started. This was Dan's idea back in last fall, and all the other stuff came later.
So can you explain more about this one? Like,
Yeah, that's very interesting. Could you explain more about BitUSD and how does it maintain? I know I've read about it, but how do you maintain the parity to $1?
Well, basically, what you read and what actually is happening now is probably different because we just changed something. But basically, you can, when you have someone who wants to go short on BitUSD relative to BitShares X, and they think BitShares X is going to go up and they want to leverage up, and they have extra collateral, they can put in a short, and if that's matched with someone who wants to buy BitUSD, then the network basically prints the BitUSD and gives them to the buyer, and the seller has his collateral locked up. And if the price falls too far relative to the real USD, then there's a margin call, and this short position buys back someone's BitUSD. So all the long positions are fungible. The BitUSD is just the stable asset in the contract for difference, and the BitShares X is the one where you get the leverage, and you have the backing collateral. And it's pegged because people can only create new BitUSD at $1, and all the BitUSD that currently exists is backed by this implicit demand where you have more than that much value of collateral tied up. So you always have a buyer who's willing to buy back, whether they made a profit, whether they sold the BitUSD at $1 and then BitShares X went up, and so they'll buy back their dollar. And then on the other side, you have people that are getting forced margin calls when the price moves too far. And it's basically pegged to the dollar because everyone thinks it's pegged to the dollar. We recently introduced the price feed restriction, which prevents new shorts from entering because too many people want to go long BitShares X, and too few people believe that the peg works, that we're just saying, screw it, we'll use price feeds to convince people that it's actually pegged to something and then let it float.
At this instant of time, if I might ask, what's its current sort of rate? Is it at a discount, 98 cents to the dollar?
I can check right now on the exchange. 1 sec.
Yeah.
So this is one external exchange. Says the buy price is 96 cents if you want a BitUSD.
So I can get $1, one BitUSD for 96 cents.
Yeah, so that's right. So that by itself is like, wait, that doesn't. What does that even mean? So some people say, okay, that means the peg is broken, and so you shouldn't buy BitUSD because it'll never be worth $1. Other people will say, oh, when the peg is restored, that'll be worth $1, so it's a discount, guaranteed 10% return. And then you have all sorts of stuff in between where people think that it's at a discount, it'll stay at a discount, but you'll always be able to trade profitably as long as you're trading towards the peg. A lot of different stuff. I recommend just wait until it actually is maintaining parity, like you can look at an exchange and it's working, and then we'll go around promoting it. Because it's an experiment. It's an experimental this whole thing is a total experiment. So
You were mentioning about collateral. What is the collateral, and how does collateral get introduced to the system?
so if I have BitShares X and I want to short BitUSD, which is the only way BitUSD ever created, I put down the collateral first, and then when I'm matched with a trade, that BitUSD is created, and my collateral on my half of the trade is what backs that much USD. It's not exactly that BitUSD, because although BitUSD are fungible, but it backs that much BitUSD. So it comes from people voluntarily putting it down to short.
And so the collateral is in the form of what is it in the form of? In the form of BitShares X.
Yeah, in the shares, BTSX is the underlying. It's like the coin.
I see. And then also, you were saying that the network printed more BitUSD. Sorry, printed more BitUSD, right? So, what does that mean? What does the printed mean here?
It means that I can sell BitUSD I don't have. That's how the network creates BitUSD, as individuals who have a lot of BitShares and who want, or not even a lot, just any amount, and who want leverage because they think it's going to go up. They can sell BitUSD they don't own as long as they find a buyer at that price. So the buyer takes BitShares X and buys BitUSD with it. The seller takes BitShares X and puts it down as collateral, and then half that much worth of BitUSD, according to the price they're matched at, is created and given to the buyer. So again, from the buyer's perspective, it's just I have BitShares X on the internal market, I press buy BitUSD, the order's matched, I have it. From the seller's perspective, if you don't already have BitUSD, you can just sell normally, but originally, or at any time, someone can short at the current price. So from the seller's perspective, they're putting down BitShares X and they're getting more BitShares X, and part of their BitShares X is locked up, and they need to unlock it.
So it's been at least an hour and a half. I know you're kind of tired by now. I don't want to keep you for a whole lot longer. So could I just, as a wrap-up, ask you two questions? The first is, what recommendation do you have for developers? How do they get started? Where would they want to go? What would they want to download or check out? How do they get in touch with you guys? And if folks are out on the East Coast, do you guys have like office hours or something? You know, can they just drop in and say hi?
We don't have office hours. Yeah, we've had some meetups, but those aren't very big. I think the best way is just contact us directly. Still, okay. I mean, I can tell you there's repos. There's BitShares Toolkit. There's the BitShares X repo. There's the DNS repo. I can point you towards all those. There's not really a great getting started for developers page, although the individual projects might, like the DNS DAC. The site is .p2p.io, and then you will probably have like very specific instructions, like, hey, developers, you can download, clone this. Here's how you build it. Here's how you get involved. But right now, we still want people to do that. We just haven't written like the help guides. But if you contact us directly, we'll help you out.
Okay. And if there was a sort of low-hanging fruit from a developer perspective, what would that be? What would you say? Hey, check this out.
DNS, definitely.
Okay.
It's very early in the process. It's not just us and me or me or whatever. It's like there's still a lot of stake to be obtained. You're still getting.
Would you say DNS because of the DNS problem, or would you say DNS because it's metadata on the blockchain and one application is DNS?
Both.
Okay.
It's like someone is going to do this no matter what.
Right.
Might as well just do it right now. It's somewhat profitable. Give us a little head start. Let's just do it right now.
Okay.
If you get involved, contact anyone on the team. We can definitely give you a job right away. You'll get paid in early stake of this network right away.
Okay.
There's delegate positions. There's plenty of opportunities, but you just contact us.
Okay. Greg, any questions, Greg?
Yeah, I actually have a question regarding DNS. My question is, are you planning on using the Namecoin specifications for BitShares DNS, or are you planning on inventing your own?
The guy I put in charge of that seems to have made something that's pretty much a subset of the Namecoin spec.
So it's going to be somewhat backwards compatible, but not completely?
Backwards compatible meaning what? That you can copy a Namecoin resolver and it'll work with the DNS resolver, or with the P2P resolver, or which one?
Well, I mean, if you mean that it's a subset of the Namecoin specs, that everything that the format of that subset is follows the same rules as the one in Namecoin.
Yeah, okay, let me put it this way. I think we support everything they actually do. I don't know that our spec is backwards compatible for everything that their spec claims that it can do. For actual, like, if there's a working system out there somewhere for it, we should have it in our spec.
Okay, well then let me try rephrasing. Is there anything that you guys have done that goes against their spec?
Not yet, but we're not theoretically opposed to doing that, because we are averse to doing that to the extent that the Namecoin infrastructure is still useful. So in the short term, it'll be pretty much Namecoin compatible.
Okay. Do you guys have any interest in collaborating with them? You know, obviously not on the blockchain, but collaborating with them on the specifications.
Yeah, sure.
Okay.
Yeah, there's if you contact me, I'll get you in all the different chat groups and stuff. Derek, the guy who has wrote this spec up till now, he wants more feedback and more people involved.
Okay. And what about the status of the DNS chain fork? Last we spoke, I think you were thinking of redoing everything from the current point that DNS chain is at?
No, yeah, at that point in time, I don't know. Basically, I took DNS chain and I made it work for the version of .p2p that existed at that time. So I'm sure both are extremely outdated, and we basically have to start from scratch probably.
Okay. Well, we can definitely chat about that. I'm happy to collaborate there.
Great.
We have another person with a question.
I'm Paul. Sorry I come to the meetup late. Forgive me if the problem is already answered. My question is that a lot of your applications, the spread of power among different parties, it's kind of similar technically or the use case-wise to BitGo, multi-sig protocol. Is there any similarity or any kind of overlap between multi-sig and BitShares?
Multi-sig is just one tiny application of everything you can do. BitShares are basically application-specific blockchains which can do whatever you want, including multi-sig.
Yes, and the company such as BitGo, they already expanded to enterprise cases like the company procurement process need to go through multiple people's signature, and it's kind of similar to what your voting use case.
I understand what you're saying. Yeah. So I think your general question is what sort of like types of governance you can have within your DAC.
Yes, I'm finding this use case because I'm building a service. I have a use case, and I'm considering what kind of technology I should use. And I haven't tried yours, but I have already tried multi-sig, and it seems to be working pretty well. So,
we are more like we'd be able to provide you with a toolkit for you to be able to build your own system and support you in that. None of the systems are a great fit for that, but it's possible.
Okay.
Like we don't even have basic multi-sig in our DACs right now, just because we haven't built it in yet.
Mm-hmm. Yeah. Okay. Yeah, I'm glad to learn about this today. The technology stack.
Sorry?
I'll look into your technology stack tonight, and so the best channel to offer feedback and Q&A is just go to your online channel.
You could send questions to me.
Okay.
What I'll do is I'll collect all the questions and I'll send them to you by email.
Okay, cool. Yeah, thanks.
One more question, I think.
Yeah. So if I were to write a decentralized application in BitShares, let's say I'm comparing that with Ethereum, which is not launched, right? So in Ethereum, I could write something in Python-like language, and it's executed on all the nodes of the network, and it works in a centralized way. So how does it look like in BitShares?
It looks like you take the code and you build your own. So here's a comparison. The way to compare BitShares versus Ethereum as platforms for your decentralized app is Ethereum is general purpose and lets you do anything, and BitShares are application specific and they do the things they pick the best. So if your app is one where the business logic is simple and it's going to be a competition about operating at scale, that's something you would want to use BitShares for. If your DApp is not, it would benefit a lot from having the flexibility of basically dynamically modifying the rules by adding new smart contracts without code changes. If your DApp has a lot of a lot of different rules, which each individual path doesn't go down very often, like basically more complex stuff for like interconnected. I want to have this reputation that's interconnected with this, and I want to be able to define my own reputation functions and stuff like that. Those type of apps for now are like probably better on Ethereum, and then apps where it's like, oh, DNS, right? Like name to value resolution. We want to do like 3,000 per second. That's something you'd use BitShares for.
Okay.
But that said, we are working to get eventually a scripting environment built in so that the ease of launching a new DAC will be similar, and then eventually, hopefully, these separate DACs. For example, the best example is BitShares X. Having a scripting environment within BitShares X, which is just like Ethereum, you can do whatever you want, but people will only use it for whatever this DAC is about. So for BitShares X, it's about finance. Basically, it'll be exactly the same thing as Ethereum, but you can write smart contracts related to financial instruments, and then you don't have to incur the cost of all the other smart contracts that are writing on that blockchain.
Right. And you don't have a scripting language at the moment, right?
No.
So how do you write a DAC now?
It's just you write all the validation in C++.
Right, and all the code, how do you get all the code executed on all the nodes? Do you change the actual BitShares code or just fork it? And so do you?
Think of it like Bitcoin and Bitcoin's clones.
Right.
Bitcoin, which provides some basic functionality.
Or new miners, or well, not miners, but stakeholders, I would say, something like that.
Or if you offer 10%, then they will sort of market it to their existing customers.
Yeah, but still, it's sort of they need to run a brand new software. They don't run the same.
Yeah, it's a different. It's just they're all separate actual applications.
Also, basically a toolkit to write something like new decentralized application with brand new network, brand new participants, everything.
Yeah.
Okay.
So, not to put you on the spot, and as a last question from me, I know there was a recent, one of the forums talked about Vitalik and Laram meeting, and there was some meeting of the minds, and there was some conversation there. Any progress on that end?
Yeah, so this is one of those things where like our marketing guys like made it into something bigger than it is. Basically, Vitalik came over and he talked to us, talked a lot with Dan. They agreed on most of the important stuff, and so Dan was like happy about that, and Vitalik and Dan both said that it's possible to have like, I mean, we're doing so much stuff in common. We have so many of the same goals that we're probably going to collaborate in one way or another, officially or unofficially, within whichever words we're allowed to use. Given our arrangements, we're going to either officially or unofficially collaborate on a lot of stuff. But on the other hand, that's not an official. If Ethereum does not have any official partnerships with anyone, and neither does BitShares. Is not even an organization. It's just a loose collection of entities. So that really doesn't.
And what
just means we talk.
Are Stan and Dan related? And Stan came up with one post, and then Dan elaborated on DAX. Who's the creator of the DAX? I mean, this is just for trivia purposes.
It's Dan, pretty much.
Okay.
I think Stan made up some of the metaphors, but
some robotics something. I've forgotten. There was some post on that.
Right. Yeah, pretty much Dan.
So I'm still a bit confused about some of the terms. Though there's like AGS, PTS, PhotoShare, and then BitShares, and I try to.
You explained that earlier. So.
Yeah. I'm just still kind of confused.
Yeah. So.
How about give us a one-liner? Yeah. We're going to wrap up. Why don't you take the next few minutes to do a wrap-up, and then we'd like to thank you for taking the time and the effort and the energy to sort of to do what you just did.
Okay. So what one-liner wrap-up about what BitShares is, or what each thing
I
is?
think he had a question on what is AGS and what is PTS. I don't think he was here early enough when you brought it up. Maybe a one-liner on AGS, PTS, and anything else you want to add to wrap up this whole conversation.
Okay. So AGS was a crowd-funded donation, which is also sort of the distribution list for people that make new DACs and want to allocate their initial shares. So we've all sort of said that we're going to do at least 10% each, and we're going to happily endorse anyone else that does at least 10% each. So 10% for AGS, which was just the initial seed, like crowd-funded money that started all this, and then PTS, which came even earlier, was just a mineable cryptocurrency with the same concept. It basically allows people to buy into the idea of a DAC before any DACs are made, and support the ecosystem. And then that would also be included in future snapshots. And then all the rest of our BitShare stuff are all individual DACs, actual networks.
Cool. Any last comments that you would like to leave all of us with?
Yeah, we need developers. Please give us your developers.
Thank you very much. It's been extremely informative. I'm sure a bunch of folks here will have questions. I'll collate them, and I'll have an email sent out to you with those questions as and when I do get them. But I do appreciate you taking the time and giving us an in-depth view into all things BitShares. And I will get the word out that you're looking for developers, and you can pay an early-stage coin. I guess that's the right way to put it, or something like that.
Yeah, we can also pay you in dollars if you like that sort of thing.
Oh, okay, the old-fashioned. Yeah, cool. Anything that you'd like to ask us? Any questions for us?
Not particularly.
Cool. If there's anything we can at the Mountain View meetup help with, feel free to shoot us an email. And okay. Thank you.
Thank you, Nikolai.
Thanks.
Okay. Cool. I'm going to now stop this broadcast.